All right, welcome to Converting General Form to Standard Form Part 1. And I've written an equation here in general form, which usually isn't very practical. And what we're going to try and do is we're going to rearrange this guy somehow so it looks like this, what we call standard form. Okay, so this is the goal to get to here. So that's what we're going to look at. Notice that on the left side we have y equals, and that stays y equals. So just as a kind of rule of thumb when we're doing all of the changes to the original equation, we don't want to tinker with the left side. So that's something that you'll be seeing as I do some of the examples. Now, before we get started, I'm just going to clear the screen, and we're going to talk about something called completing the square. So completing the square is it's a really important skill that we're going to use in rearranging these functions. So completing the square. Now, what that means is suppose you had something that looks like this. X squared plus 6x plus 9. What this is a completed square. And the reason it's complete is because if I go to factor it, I'm going to get x times another x, and then I need two numbers that have to make positive 9 that add up to positive 6. And those numbers are 3 times 3. So what I've done is I've factored the trinomial. But it's not just any factored form. It does this, which is really awesome. We get the same thing twice. Now, this looks strikingly familiar. If you think back to the standard form which we're trying to achieve, we're looking to try and get something that looks like that. So you can see there is kind of a similarity between this guy and this guy. So completing the square is one of those things. It's really going to help us. Now suppose we come along and we don't know that it's a completed square, and we have something like this. So here we have actually an incomplete square. And we're asking ourselves, what do I tack on here that will complete the square so it behaves the way this one up here did? And what we want to do is maybe look back at this one and determine, well, where did this 9 come from, I guess, is the question. So if we can figure out where 9 came from, we'll use the same thing to fill in this space. Well, okay, 9 is the 3 times the 3. And you'll notice that this number here has to be the same as this number here. And they have to multiply together to make the number at the end, but they have to add up to the number that we can see, which is 6. So in other words, what we want is we want to take half of 6. Okay, that's where that 3 is coming from. And in order to produce the 9 at the end, we're going to take half of 6, which is 3, and we're going to times it by itself, and that's how we get this number. Okay, so if you use that kind of a recipe down here, the number we want is half of 8. Okay, so half of 8, well, that's 4, and we want to take that number and we want to square it. And so that's going to become the number that goes in here. So the number we want is actually 16, and that's going to complete the square. So in its factored form, we would have an x plus 4, and another x plus 4, so x plus 4 squared. Now, that's great, but what good is completing the square? Well, we're going to get to that in a little bit. I'm just going to talk to you about what if you run into some negatives here. So let's clear the screen, and suppose we have to complete the square, and we've got some sort of a negative situation floating about. Now we want to put a number here that's going to complete the square. Well, first of all, we know that we need to take half of 12. Okay, so half of negative 12. Yeah. So half of negative 12, well, that's negative 6. But I'm going to square it, right, to figure out the number that goes in that completes the square. So this is always going to be a positive number that you tack on, and that's because of this recipe where it gets squared. So that's going to be positive 36. But when I go to write it out in the factored form, okay, this would be x minus 6 times x minus 6. And the reason for that is if it wasn't x minus 6, you wouldn't be getting the negative 12 that you need in the middle. So here's kind of the shortcut to that. Okay, so there it is in its factored form. If you have a negative sign here, then you want to put a negative sign in here. If this over here is a positive or a plus, then this over here is also a plus or a positive. Okay, so that's the idea of completing the square. And now we're going to show you with some functions what it can do for us. Okay, so the function we're going to try to look at here looks like this. So we have f of x, or if you prefer, you could say y equals, doesn't really matter. And we have x squared plus 6x. Okay, so I want to try to rearrange this to standard form. And here's how completing the square will help us. First thing is, I want to complete the square here. So I go, well, I need half of 6. So I need half of 6. Okay, that's 3. And when I square that, oh, I get 9. Okay, so I need a plus 9 here. But hold on, I can't just throw positive or plus 9 into the right side of my equation. Now here's the problem. I don't want to put a plus 9 with this f of x or with the y. The whole idea when we're done is that we have y equals, not y plus 9 or something like that. So there's another way that we compensate for this plus 9 that I just put in, and that is I take it out. Okay, if you put a 9 in and you take a 9 out, you haven't changed the function. And now what I can do is take all the ingredients that are here, these first 3, and write them as a factored x plus 3 squared. And then I still got this minus 9. So I go, hey, there it is. It's all done. So I got, this is my standard form for this same function. And of course, being standard form, it makes it really easy if somebody comes along and says, hey, where's that vertex? I can say, well, it's at negative 3, negative 9. And I didn't really have to think about that a whole lot because standard form makes it real easy. So that's where I'm going to stop with part 1 here.